Question 5. Nice question, this one, I think. So, proportion, just read fraction basically. So, 135 out of 400, write it to 4 decimal places, job done. Use the margin of error formula, okay. You want an interval though. So, margin of error, fine. So, you just put that into the calculator. So, 0.05, that's your margin of error. That's plus or minus basically. And it's plus or minus the proportion that you worked out in the earlier question. Notice this is part 2, it's not part B, so you have to use part 1. If they didn't want you to use part 1, this would be B, it wouldn't be part 2. Okay, so plus and minus 0.05, you get this proportion here. I've turned it into percentages. I'm not really sure you need to, but hey ho. This one, if you wanted it as a percentage, 33.75%. Right. Okay. Right. More accurate. More accurate means use the formulas from the log tables, but still exactly the same method. You're still going to plus minus, but you're just going to find a different error. Now, you want an error of the proportion, so I'll just show you what that is. Here, look, so hopefully you can see that. So standard error of the proportion is this guy, page 34. Don't use the one above that here. You wouldn't be able to anyway, you haven't got all the information, but that's the standard error for the mean, so we're going to use this one instead. P is the fraction that we had in part 1. The only thing you need to remember though is if we're using a formula, and this is for every single one of these, if you're doing an error, 95% is 1.96 at the start. You have to put that in for the error. So yeah, use the formula. P is the fraction we had at the top. N is 400 because there's still 400. Notice again that this is part 3, so we're still using all the numbers from the top. Put all the numbers in. You get 0.0463, and then you just need to plus and minus this from your proportion that you had at the beginning. So instead of using 0.05 in part 2, we're using 0.0463, so basically 0.05, but it's a little bit different, a little bit more accurate. So we get to here, here's the answer. Yeah, move on. Right, part B now. So part B, completely different, don't use anything that we've just done. We have a sample of 500 people, and we've got to carry out a hypothesis test. So the null hypothesis is that from 2019 to 2021, everything's the same, nothing's changed. Yeah, even though the numbers are slightly different. So even though this is 20 quid, that's the mean from everything. This is 22. This 22 might have just been a bad sample of 500. It might be, look, it's still 20. If I sampled other people, I might get 18. If I sampled other people, I might get 20. But this is still the same. Okay, 22 does seem a bit high though. It seems like it's changed quite a lot to me. If that was 2116, then you might say, oh look, it's not changed. But anyway, your null hypothesis, nothing changed. Your alternate hypothesis, so this is H0, your H1, it has changed. It's the opposite. Right, so this is always Z-scores. Because we have our sample of 500, it's this Z-score formula rather than the more simple one. I'll show you the more simple one. Here, it's not this guy. It's the one on the top of the next page because it has an N in it. The 500 is the N. So your X bar is your sample mean. So sample mean is your 2216 from the top. Your mu is your mean from the population. So that's the 2019 mean. So that's your 20. 8.12 is your standard deviation. They give you that in the question, and 500 is your own. Put all that in, you get 3.77. Now you've just got to check that against plus and minus 1.996. So if it's within the 1.96, then it's not actually changed that much. So if you're, let's say you get a 1 is in between this range, and that means that your means haven't changed that much. 3.77 though is way outside this range. It means your means changed a lot, and because it's changed a lot, this no change thing can't be true. Okay, so not changing very much is being 0 or 0.5 or -1. Anywhere in there is not changed a lot, but 3.7 is changed an awful lot. So we reject H0 because you're outside of the interval. So reason, not in interval. And then you accept the alternate hypothesis because you rejected H0. You've rejected the null, so you've accepted the alternate. I should probably, I have put does not lie in the interval, so perfect. Done.